Hello and welcome to this episode. So in this video, I'm going to show you how to index 1D arrays, and in the video that follow, I will also show you how to index 2D arrays, and I'll make another one for multi-dimensional arrays. So let's get started. I'm going to create a new notebook here, and I'm going to rename it. I'll call it indexing 1D arrays. Okay, so as usual, I'm going to import NumPy as NP, and I'm not going to import Matplotlib because we are not going to do any plotting here. It's just about how to index one-dimensional arrays. So I'm going to use the linspace function that I showed you in the previous videos to generate some one-dimensional array, and then I'll show you how to index into it. So I'm going to call this data is equal to mp.linspace. So I want to generate 10 numbers between 0 and 1. So if I print data, you can see that there are 10 equally spaced numbers between the range of 0 and 1. So how do you index 1D arrays? And the truth is, one-dimensional arrays in NumPy are very similar to vanilla list in Python. So everything you know about indexing regular Python list applies here, except some few differences in terms of vectorization and in terms of also indexing based on multiple indexes or accessing multiple indexes at the same time, which is something that is not supported by vanilla um, list in Python. So let's see. Like everything, indexing in Python and in most programming languages starts from 0. So if I do data 0, I get 0 0.0 because of course this is the first index and it contains the number 0 0.0. So if I index 1, then you can see that it has 0 0.111111, and that is because it is what is contained at index 1 of this NumPy array right here. So up until this point, we've not done anything that is different, or yes, different from what you know about vanilla Python list. Okay, now one more thing that you can also do, just as you can do in Python list, is you can index from the end of the array. So if I do -1, it means I want to access the last element, which is here. And if I do data index -2, then I get 0.8888889 because that is the second element from the tail of the array. Okay, so these are all regular indexing skills that you already know about list in Python. Now let me show you something that is a bit different and is specific to NumPy arrays. So what if I want to access items in index 0, 2, 4, and 6? The way to do that is to pass a list of indexes to access those elements. So what I mean is I can say data and then I pass a list. So I wanted index 1, I want index 1, or let me start from index 0, I want index 2, I want index 4, and I want index 6. So if I execute this, you can see that index 0 gives me 0, index 2 gives me 0.222222 because this is what is stored here. Index 4 gives me 0.4444, and index 6 also gives me 0.666667. So this is something that you can do, and it is a vectorized implementation of the indexing that you know from regular Python lists. So always remember that anytime you want to access items from multiple indexes, you just pass, multiple indices, you just pass the indices as an array, and then you index into your NumPy array to get those items over there. What more can you do with this indexing? So just as you can access elements, you can also set elements. So if I do data 0 is equal to 200 and then I print data, you can see that now at index 0 the value is 200 because I changed it using this statement right here. You can also change items at multiple locations using this indexing style that you learned here. So if I want to change what is at index 0, 2, 4, and 6, if I want to change everything at these indexes to 0, I just supply a list of those indices and then you set the value you want to place there. So if I do this, you can see that now index 0 is 0, index 2 is 0, index 4 is 0, and index 6 is also 0. So this is one way of changing values in your NumPy array. You can either set by using a single index, or you can supply a list of indices and then you set a value that you want all these indices of the array to have. Okay, there is another way of accessing items in your array, which is called slicing, which you should know about if you already know about Python list. So if I do data and then I put a colon, what it means is I want everything in data. Okay, however, if I do data and then I say 0:5, what it means is I want everything in data starting from the 0th index to 1 less than 5. What I need you to remember is the last index you specify here is not inclusive. So it is going to go from 0, 1, 2, 3, and 4. It wouldn't get the 5th item. This is a major source of confusion for many people. So always remember that when you slice into your 1D array or any n-dimensional array, the last index you specify is not inclusive. So it is always going to do up to 1 less than what you specify. So if I access this and I print, you can see that it gets all the values from index 0, index 1, index 2, index 3, and index 4. And because we're counting from 0 to 4 is indeed 5. Okay, now you can also slice by saying, so if you omit the start index, it assumes that it is 0. So what this means is get me all the items starting from the 0th index to the 4th index. And this code right here is equivalent to what we have here. You can confirm that by checking if they are equal. And indeed, this is okay, so this actually did NumPy equality, where it is checking that every item in both slices are the same. So what happens is it checked and it verified that indeed when you do data colon 5 and then you do data 0:5, you are getting entries that are the same. Okay, so one other thing you can do is you can also index by stating the start index and omitting the end index, and that also assumes you want to index from the given start index all the way to the end of the list. So if I do this, what it means is that I want to get all the values from the 4th index all the way to the end. So you can see that the values that are shown here are values from the 4th index of the data ND array all the way to the end. And one last thing I want to show you is that you can also index using the negative indices, which indicates that you are actually starting from the bottom. Okay, so if I do data, if I want to get from say -5, what happens is it's going to read from the 5th element from the bottom. So let me actually print the whole data here so that we get to compare. So you can see that from the bottom or the tail, this is -1, -2, -3, -4, and -5. So when you index starting from -5 and you don't specify the end index, what it means is that you want the fifth element from the tail all the way to the tail end of the array. So -5 to the end gives you everything from the fifth item starting from the tail all the way to the end. And of course, you can specify two negative indexes to index into your array starting from the tail. So these are the indexing and slicing skills that you need to understand about 1D arrays. They are pretty very simple to understand, and the beauty is that what you have learned here applies when you go to two-dimensional arrays and to n-dimensional arrays as well. So thank you very much for watching this video. In the next video, I'm going to show you how to index into two-dimensional arrays, and then from there we'll take it up onto n-dimensional arrays. So I'll see you in the next video.